In today's video, we're looking at problem solving and program design and program implementation. Using a computer to implement a solution can be done in two phases. Phase 1 can be classified as problem solving and program design, and phase 2 can be classified as program implementation. Phase 1 Problem solving and program design. How the program will work must be designed by the programmer before any writing of the computer code is done. Phase 1 Problem solving and program design. There are 5 steps in this phase. Step 1 is problem definition. Step 2, the solutions are proposed and evaluated. Step 3, the solution that is most efficient is selected. Step 4, the algorithm is developed. Step 5, the solution is tested and validated. In phase 1, the first step is problem definition. The problem is stated and the input, processing, and output requirements are identified. An IPO chart is used to record the requirements. The IPO chart is also called a defining diagram. Here we have an example of a IPO chart, and in the next slide we'll be looking at the actual question that is needed for this IPO chart. Step 1, which is problem definition. A student wants to find the total of two numbers, which are whole numbers, entered by him or her. He or she wants a display of the total of the numbers. And here we have the input, the processing, and the output. All right, step 2. And we're looking at the problem solving and program design phase. And step 2, the solutions are proposed and evaluated. To solve the problem, different manual or computer-based methods are proposed. Step 3, the solution that is most efficient is selected. The most efficient solution is selected from the different manual or computer-based methods that were proposed in step 2. Step 4, the algorithm is developed. To represent the computer-based solution for the given problem, step-by-step instructions are created. These step-by-step instructions are called an algorithm. Step 4, the algorithm is developed. The algorithm can be represented in 3 main ways: narrative, which is natural language, pseudocode, and flowcharts. The instructions to solve the given problem can be written in a pseudocode or on a diagram called a flowchart. Okay, so let's look at the example. A student wants to find the total of two numbers, and these two numbers are whole numbers entered by him or her. He or she wants a display of the total of the numbers. So here we have the input would be the two numbers, and they would be whole numbers, and these are entered, right? Then he wants to display the total of the numbers, right? And the sum, which is the processing, would be sum will be equal to num1 plus num2. So the input would be num1 for the first number, num2 for the second number, and then the processing, as I said before, sum would be equal to num1 plus num2, which are the variables num1 and num2 over here. And then the output, which is the display that the person wanted, would be the sum here, right? Here we have the narrative, which is a natural language. And here we have the problem definition. A student wants to find the total of two numbers, and these numbers are whole numbers, entered by him or her. He or she wants a display of the total of the numbers. So here we have the narrative algorithm in a narrative form. So we have set sum equal to 0. Store the first number in a variable called num1. Store the second number in a variable called num2. Use a formula to get the total, which would be sum is equal to num1 plus num2, and output the sum to the user. Pseudocode. And the problem, again, the student wants to find the total of two numbers entered by him, and he or she wants to display the total of the numbers. So here we have the pseudocode, and we have start, then we have declare, num1, num2, sum as integer. Then we're going to initialize sum, the variable sum, to 0. Then we're going to read num1, read num2, and then we're going to assign the variable sum equal to the addition of num1 and num2. And then we'll print sum, and then we'll stop. So here we have a flowchart for the problem definition. A student wants to find the total of two numbers entered. He or she wants a display of the total of the two numbers entered. So here we have the flowchart on the right and the problem definition on the left. So we have start, then we have read num1, read num2, then we're going to assign the variable sum equal to the addition of num1 plus num2, and then we're going to print the sum, and then we'll stop. So phase 1, which is a problem solving and program design phase, includes problem definition. And step 2, the solutions are proposed and evaluated. Step 3, the solution that is most efficient is selected. Step 4, the algorithm is developed. Step 5, the solution is tested and validated. Phase 2, program implementation. In this phase, machine executable instructions are converted from a human readable algorithm. Phase 2, program implementation. Continuing from phase 1, which is program design, we will have step 6. So step 6 includes source code creation. Step 7, translation and or linking. Step 8, execution or running the program. And this will include the testing and debugging of the program. And then step 9, maintain the program. Okay, step 6, source code creation. The logic of the programmer's solution to the problem is converted into the syntax of a high-level program, such as Python or Pascal. Step 7, translation and or linking. This step can be transparent to some users on some computer systems. The source code in this step is then translated into machine code using a compiler or interpreter. The machine code is needed so that the computer can execute the program solution. Phase 2, program implementation, step 8. Execute or run the program. This involves the testing and debugging of the program. The test data is used when the program is run to see if there are any runtime and logic errors. If any mistakes are found, they are fixed by the programmer. This fixing of the program to produce the correct outputs or output is known as debugging. Step 9. Maintain the program. Any updating of the program that is required by the users or owners of the program in the future is done by the programmer. Documentation can also be done in this step. The programmer writes the documentation to explain how the user uses the program. Technical guides and user manuals are written by the programmer for the users or owners of the program. Phase 2. Program implementation. The first step is source code creation. Step 2. Translation and or linking. Step 3. Execution or the running of the program. And this is done to test and debug the program. Step 4. Maintain the program, and this could include documentation in this step.